are just a way of sorting out information. So it's a bit like a table. It's got, we start and we just have a way of, it's like a table of information we put in there, okay? We look at matrices and we label them with a capital letter. So a matrix always has a capital letter to name it. So this is the name of the matrix. And then, or the matrix, sorry, matrix is the singular, matrices are the plural. And then there are different what are called elements within a matrix, within square brackets. So you must, if you're asked to draw a matrix, you must show the square brackets. This is the name of the matrix. Each of these are called, can you remember the name of them? Elements. And those elements are named, I'm fairly certain I asked you to move. Those elements are named with the lowercase letter of the matrix and the row and column number. I'll show you what I mean by that. Okay, so we have to look at the number of rows and the number of columns. It's actually really important when we look at a matrix. So rows go which direction? Across. Columns go up and down. Okay, so this here is a 2 by 2 matrix because it's got row 1, row 2, column 1, column 2. Okay, so it is called a 2 by 2 matrix. And we label a matrix by its dimensions, so it could be 2 by 2, it could be 3 by 2, it could be 4 by 1, whatever it is, and by a letter. Now the rows always come first. So 2 by 2 means 2 rows and 2 columns. Rows are always first. So often in these questions, particularly in a non-calculator section, I'm going to give you this. So I've given you A equals 3, 4, 5, 6, okay? And then it says find A 2, 2. A, and everyone goes A22, or they go, oh, they meant squared, but they put it lower, or they look at it in a really weird way, or something happens, okay? In particular, they look at it and say 22. It actually means A22. So it's saying it's an element. This lowercase a means an element in matrix A. That's what the lowercase says. I'm asking you for an element in matrix A. What does the 2, 2 stand for? Row 2 and column 2. So which element in matrix A is in row 2 and column 2? 6. So A22 equals 6. So it's this one. So what if I said A12? What's that saying? An element in matrix A in row 1, column 2. So therefore, it equals 4. They always ask you one of these questions and everybody messes up because they've just forgotten about this little thing, okay? So elements are labelled with a lowercase letter for the matrix they're in, the row number, and then the column number. Any questions to there? The dimensions of a matrix are the number of rows by the number of columns, always in that order. It always goes rows, then columns. And a matrix is labelled with a capital letter. Everyone okay to there? All right, so the dimensions are really, really important because we're going to use those dimensions for everything from now on, okay? So if we look at adding or subtracting matrices, there are some rules to do this. Now, just so you know, a lot of people are like, why do we even do matrices? Matrices is a way which we can actually do quite complex maths when when you use businesses and things like that. Matrices is also a major part of the Year 12 apps topics. Okay, so a sixth of the course next year uses matrices. Now, in that topic, you don't have to do as much of the non-calculator section. It's more the calculator stuff, and we teach you some more topics. But you need to have a basic understanding, particularly of using your calculator for matrices and of how to do this, what the squaring means and things like that. So just for your knowledge as to why we do it. And you get more applications of matrices in Year 12. So how you actually use some of them, okay? So adding and subtracting matrices. If we add and subtract matrices, we're looking at the dimensions of the matrices must be the same. What I mean by that is if I have what's the dimensions of this one? 2 by 2. If I have a 2 by 2 and then I want to add what will be the dimensions of this one? 2 by 1, 2 rows, 1 column. Okay, these are, do they have the same dimensions? Same number of rows, same number of columns? No. So you can say cannot be. Done. So the dimensions have to be the same to be able to add them or subtract them. So instead, let's try a different one. When we look at this, we need to go, we need to add, we're adding. When we look at this, we are saying, okay, we add each of the elements, so the ones in the same position, to each other. So when we add or subtract, we add or subtract each of the corresponding elements. So by that, I mean row 1, column 1. In each of them, we add them together. So 4 plus 5 is 9. We write our answer in a matrix form. So we'll end up with a matrix of the same dimensions, because then we look at the next one. -1 plus 2 is 1. There'll always be some negative numbers in here, so you need to be aware of that. 3 plus 4 is 7. And 4 plus 1 is 5, and that's your answer. Where sometimes they get a bit confusing is when it might be like this. All right, can we subtract these two matrices? Yep, because they have the same dimensions. So we need to look at it. So we're going to end up with the same dimensions for our answer. So we're saying 5 take -3. So 5 take -3. 8. Okay, so when it's take and there's negative numbers in there, just be aware that you need to know your integer rules for that. A lot of people just mess up little number things here, because take and a negative end up being a positive. So we end up with 5 plus 3, which is 8. So -2 take 4 is -6. 3 take -5 is 8 again, because it's 3 plus 5. So that's where our answers come from. So again, it's just whatever position this one's in, we subtract by that, and we get our answer in the same position. Everyone okay with that? All right, so then we then go to, so that's for addition and subtraction. We then go to multiplying. Now we need to know the difference between multiplying by a number and multiplying by another matrix. So if we have a matrix multiplied by a number and matrix multiplied by another matrix. Next lesson, I'll go through the multiplying by the matrix because it's a bit more confusing and I think that we won't have enough time today. Today, I'm just going to do the multiplying by a number, and sometimes that's called a scalar. So multiplying a matrix, so you've got one matrix by a number. It's also called a scalar, and I think in your test they use the word scalar, so just be aware, okay? So what that means is 3, 4, 2, negative 1, 5. Something like that. If I said 3, I'll write that times. It'd be something like that. How can anyone remember how we find the answer to this? We do. We multiply the number, we multiply the scalar by each element. So this only works when it's a whole number multiplied by a matrix. So we say 3 times, so we go 3 times 4 equals 12. 3 times 2 equals 6. 3 times negative 1 equals negative 3. 3 times 5 equals 15. Everyone okay with that? All right, so often what ends up happening, a mixture of that, so a mixture between the addition and the multiplying by a scalar is a question like this. So you might get given, and this is very common, you get given a whole heap of you'll be given a whole heap of different matrices with different letters attached to it, okay? Then it's going to ask you questions like this, so it might just say determine A plus B. And so if you get asked that, you need to draw the 3, 2, 1, 4, which is A, plus 0, negative 1, 2, 1. But the question is just going to say A plus B. It's not going to draw out the matrices for you. And so we end up with 3, 1, 3, 5 as your answer. Everyone okay with that? I think you got good to there. The harder one, which is definitely in all your tests, is something more like this. Determine negative 2 times A plus 3 times B. So this time we have to multiply by a scalar and then do the addition. You have to do the multiplying by the scalar first. Why is that? PEMDAS, okay? So if we look at it, we've got to look at A and we've got to go, okay, so what we're saying is we're saying negative 2 times 3, 2, 1, 4 plus 3 times 0, negative 1, 2, and 1. So we end up having to rearrange them as we go. So you'd usually get a mark for this first one, negative 6, negative 4, negative 2, negative 8. That would give you a mark. Then we're saying plus 0, negative 3, 6, and 3. And then we have to add them together after that. You need to show the line of working out there. So this line, the line I just did, that's going to get you marks for the scalar side of things. And then your next line will get you the marks for the addition. So negative 6 plus 0 is negative 6. Negative 4 plus negative 3 is negative 7. Negative 2 plus 6 is 4. And negative 8 plus 3 is negative 5. And that's your answer. So that question could be worth 3 marks. So it's important that you know how to do it. Any questions? I will go through the multiplying and some worded questions tomorrow, but I would suggest that you go through some of those, the booklet questions or practice exams as you go, so you have questions to ask me tomorrow, okay? You've still got a couple of minutes to be able to keep working.